Find the inverses of each of the following transformations. Give your answer in matrix format. So here we have a translation of 5 right and 4 down. So the reverse or the inverse would be that we need to go 5 to the left and 4 up. Here we have a dilation of factor 0.4 in the x direction and 0.25 in the y direction. So that's going to be 0.40, 0, 0.25. And we want the inverse, so we'll just raise that to the -1. And let's just clear everything here to make space. So we've got 0.4, 0, 0, and 0.25. And we want the inverse. And that's going to give me 2.5004. And of course, that wasn't the only way of doing that. A rotation of 70 degrees around the origin. Well, we know the original matrix for that is going to be cos 70, negative sine 70, sine 70, cos 70. Well, the inverse is just going to be to rotate back 70 degrees. We know this is anti-clockwise, so just go clockwise. So our inverse will be the cosine of negative 70. Negative sine, negative 70. Sine of negative 70 and cos of negative 70. A reflection in the line through the origin with slope -3. Now we know that reflections are self-inverses, so it's going to be the same as the original matrix. Now if you want, you can convert this to an angle. I'm going to do it with the m formula, which I know is 1 minus m squared over 1 plus m squared, 2m over 1 plus m squared, 2m over 1 plus m squared, and negative 1 minus m squared over 1 plus m squared. Now, m is equal to -3 here, so 1 take away -3 squared is 1 take away 9, so that's -8, and 1 plus m squared would be 10, so that's -4/5. So this one's going to be -4/5, and then this one will end up being -6 over 10, so -3/5. This one's just the negative of that one, so we can write that down as 4/5 now, and this one's the same as that one. And of course, that's the original matrix, and also it's the inverse because reflections are self-inverses.